After learning a little bit quantum mechanics from the chapter 1 of the book Modern Quantum Mechanics by J.J. Sakurai, we are in a position to solve some problems from this same book. Now, in today's lecture, we will going to solve from question 1 to question 3 from the same book. So here in question 1, we are asked to prove express this commutation relation by some anti-commutation relation. So let us do that. A, B, comma, CD is equal to A, B, CD minus CD, AB. Now, here we will add some other terms and subsequently subtract that terms. Let us do that. A, B, C, D. Let us add terms and other terms plus A, C, B, D. Then subtract this term A, C, B, D. Then subtract another term A, C, D, B. Add this term A, C, B. Now add another term which is CA, DB. Then subtract the same term CA, DB, and then last term is minus CA, CD, AB. Now if we rearrange this term, what we will get? We will get A, BC plus CB D minus A, C, BD plus DB plus AC plus CA DB minus CAD plus DA into B. Now what it is? Is A anti-commutation between C, B minus AC anti-commutation between D, B plus anti-commutation between C, A into DB minus C anti-commutation between D, A, B. So hence we prove the following question. Hence prove. Now let us solve the equation 2, where we are asked if X is a matrix which is not necessarily Hermitian or not unitary, is written as X equal to A0 plus sigma into A, where A is a unit vector, A is a vector, 3-dimensional vector, and sigma is value of sigma is sigma 0 equal to 1 0 0 1, sigma 1 equal to sigma x 0 1 1 0, and sigma 2 is equal to sigma y equal to 0 I minus I 0, and the value of sigma 3 is equal to 1 0 0 minus 1. Now let us solve the question number 1. Question number A. How A0 and AK related to trace of x. First calculate trace of x. Trace of x is equal to trace of A0 into identity plus trace of sigma dot. That means A0 into trace of 1001 plus A1 trace of sigma 1, which is 0110, plus A2 trace of 0 I minus I 0 plus A3 trace of 100 minus 1. That is equal to A0 into 2 plus A1 into 0 plus A2 into 0 plus A3 into 0. That is equal to A0. That means A0 equal to half of trace of x. So we have solved the first part of the question A. Now let us solve the second part of the question. To do so, we require the following properties of the sigmas. One, that sigma 1 into sigma 2 equal to sigma 2 into sigma 3. After solving, before solving the second part of the question A, let us see some property of this sigmas. First property, that sigma 1 into sigma 1 equal to sigma 2 into sigma 2 equal to sigma 3 into sigma 3 equal to identity operator equal to sigma 0. Let us check that. First, 0 1 1 0 multiply 0 1 1 0, that is equal to 0 1 0 0 0 1. Second, let me check it this. Let us check sigma 2 into sigma 2 equal to 0 I minus I 0 0 I minus I 0 0 I into minus 1 plus 1 0 0 0 I into minus 1 plus 1, that means equal to identity operator. Similarly, we can express sigma 3 sigma 3, we can prove sigma 3 into I. Now let us see some property again. If we multiply sigma y into sigma 2, that is sigma 1 is 0 1 1 0 into 0 I minus I 0, that is equal to minus I into 1 0 0 minus 1, which is nothing but minus I sigma 3. Similarly, we can prove that sigma 2 into sigma 3 will be equal to minus I sigma 1 and sigma 3 into sigma 1 equal to minus I sigma 2. Now let us see that what is the trace of sigma k to x. So first, if k equal to 1, then trace of sigma 1 x is equal to trace of sigma 1 into a0 into identity operator plus sigma 1 a1 plus sigma 2 a2 plus sigma 3 a3. Since sigma dot a is equal to sigma 1 a1 plus sigma 2 a2 plus sigma 3 a3. is equal to trace of a0 sigma 1 plus a1 identity operator plus sigma 1 into sigma 2 a2 plus sigma 1 into sigma 3 a3. Trace of sig a0 sigma 1 plus a1 I plus, as we know, sigma 1 into sigma 2, as we proved, sigma 1 into sigma 2 equal to minus I sigma 3. That will be minus I sigma 3 into a2 plus, as we know, the sigma 3 into sigma 1, if we multiply both sides with sigma 1, if we multiply both sides of this equation by sigma 3, we'll get what we'll get. Let us check that. Sigma 2 sigma 3 equal to minus I sigma 1 sigma 3. That equivalent to sigma 1 sigma 3 is equal to I sigma 2. That means we'll get I sigma 2 into a3. That is a0 trace sigma 1 plus a1 trace of I minus I a2 trace of sigma 3 plus I a3 trace of sigma 2. As we have seen in the first part of the question, the trace of sigma 1 and sigma 2 and sigma 3 is equal to 0. That means this will be a1 trace of identity will be 2 and others will be 0. Trace of into 0, trace of sigma 3 also equal to 0, trace of equal to 0. That means a1 is equal to half of trace of sigma 1 into x. Similarly, we can calculate that a2 equal to half of trace sigma 2 x and a3 equal to half of trace of sigma 3 x. So these three relation that we are asked in the question, hence we solved the first part of the problem. Now let us see the second part of the problem. Now here it is asked, obtain a0 and ak in terms of the matrix element x I j. Let us do that. What is now part B? That means a0 equal to trace of x into half. That means that equal to half of x11 plus x22. Now let us see that what is the value of a1. a1 equal to half of trace of sigma 1 into x. Let us see that what it is. Trace of, what is the sigma 1? Sigma 1 is 0 1 1 0, x11, x12, x21, x22. That will be half trace of 0 1, x21, 0, x22, x11, x12. So it will be half of x21 plus x1. Let us see that what is the value of a2. That will be half of trace of sigma 2, which is 0 I minus I 0 into x11 x12 x21 x22. That is half trace of 0 into x11 is 0 I x21 0 I x22 minus I x11 minus I x12. Trace, that is I by 2 x21 plus minus x12. And what is the value of a3? It's half of trace 1 0 0 minus 1 x11 x12 x21 x22. That is half trace of x11 x12 minus x21 minus x22. That is equivalent to 1 half of x11 minus x22. Hence, we solve the second part of the question, that is question B. We represent a0 in terms of xij, a1 also in terms of xij, and a2 in terms of xij, and a3 also in terms of xij. Now let's solve the question number 3. In question number 3, we are asked to show that the determinant of the 2 cross 2 matrix sigma dot A is invariant under this transformation, where the transformation matrix is exponential I sigma dot n cap phi by 2. Now let us see what is the determinant, value of the determinant of sigma dot A. Now sigma dot A equal to sigma 1 A1 plus sigma 2 A2 plus sigma 3 A3, or is equal to sigma x AX plus sigma y AY plus sigma z AZ, which is equal to 0 AX 0 plus 0 AY IAY minus IAY 0 plus AZ 0 0 minus AZ. That is equal to AZ x plus I AY x minus I AY minus AZ. Now let us check the determinant of sigma dot A, which will be minus AZ square plus minus AX plus I AY into AX minus I AY, which will be minus AX square plus AY square plus AZ square. That means minus mod of A its square. After going to solve the question, let us see another general things, that is what is the value of sigma dot n cap its square. it is equal to sigma 1 n1, where n is a unit vector, plus sigma 2 n2 plus sigma 3 n3 its square, which is equal to sigma 1 square n1 its square plus sigma 2 square n2 square plus sigma 3 square n3 square plus n1 n2 into sigma 1 into sigma 2 plus sigma 2 into sigma 1 plus n2 n3 sigma 2 sigma 3 plus sigma 3 sigma 2 plus n1 n3 sigma 1 sigma 3 plus sigma 3 sigma 1. Now, as we seen in our previous question that sigma 1 into sigma 2 is equal to minus I sigma 3, and sigma 2 into sigma 1 will be plus I sigma 3, and so on. That means sigma 2 into sigma 3 will be I sigma 1, and sigma 3 sigma minus I sigma 1, and sigma 3 into sigma 2 will be plus I sigma 1, and sigma 3 sigma 1 equal to minus I sigma 2, and sigma 1 sigma 3 will be plus I sigma 2. That means this term will equal to 0, which means, and we know that sigma 1 square equal to 1, sigma 2 square equal to also 1, and sigma 3 square equal to also 1. 1 means identity operator. That means n1 square plus n2 square plus n3 square into identity operator. That means since n is a unit vector, that means n1 square plus n2 square plus n3 square equal to 1. That means it is unit. It is identity, nothing but identity operator. Now let us see the general expression for this transformation matrix, which is exponential of plus minus I sigma dot n cap pi by 2. Let us expand this in terms of series. We will get 1 plus minus I sigma dot n cap pi by 2 plus I sigma dot n cap its square into 5 by 2 its square by 2 factorial minus I sigma dot n cap into plus minus sigma I dot n cap factorial cube by 3 factorial into 5 by 2 its cube and plus I sigma dot n cap to the power 4 by 4 factorial into 5 by 4 5 by 2 to the power 4 plus dot dot dot. Now as we know that sigma dot n cap its square equal to identity operator, that means sigma dot n cap its cube equal to sigma dot n cap square into sigma dot n cap, which is nothing but sigma dot n cap, since it is identity operator. That means this expression can be simplified, this series can be simplified to 1 plus minus I sigma dot n cap pi by 2 plus minus I sigma dot n cap pi 3 factorial pi by 2 its cube plus minus dot dot dot. And here, since I sigma dot n cap square means unitary operator, this is also can be simplified to minus phi by 2 its square by 1 by 2 factorial plus minus this also is plus this also can be written as I sigma dot n cap I to the power 4, which is nothing but 1, and sigma dot n cap to the power 4 is also will be identity operator. That means sigma dot I into 1 by 4 factorial sigma by 2 to the power 4 plus dot 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 into this is nothing but identity operator into the identity operator. Now if you rewrite this expression, that means 1 minus 1 by 2 factorial 5 by 2 square 1 by 4 square 5 by 2 to the power 4 minus so on into identity operator and plus minus I sigma dot n cap this will be, since I cube equal to minus I, that means this sign will become minus plus. That means this will be 5 by 2 minus 5 by 2 its cube 1 by 3 factorial plus dot dot dot. That means this can be simplified to cos 5 by 2 into identity operator plus minus I sigma dot n cap into sine 5 by 2. That means this operator is nothing but the rotational operator which operates the state by phi by 2. Now let us solve the asked question, that is this transformation will not change the determinant of this sigma dot A. Now suppose this is equal to, now we are in a position to solve the asked question. Now now in the question the n cap is in the positive z direction, so let us impose that things. That means the transformation operator u is equal to exponential of I sigma z phi by 2 is equal to cos phi by 2 I plus I sigma z sine phi by 2. That means cos phi by 2 0 0 cos phi by 2 and plus I sine phi by 2 0 0 minus I sine phi by 2, that is equal to cos phi by 2 plus I sine phi by 2 0 0 cos phi by 2 minus I sine phi by 2. which is nothing but e to the power I 5 by 2 0 0 e to the power minus I 5 by 2. Similarly, the operator u dagger is equal to exponential minus I sigma z 5 by 2 equal to your minus I 5 by 2 0 0 e to the power plus I 5 by 2. Now let us see what will be the u sigma a u dagger. That will be e to the power I 5 by 2 0 0 e to the power minus I 5 by 2 into az ax plus I sigma y ax plus iay ax minus I ay minus az into e to the power minus I 5 by 2 0 0 e to the power plus I 5 by 2. That is equal to e to the power I 5 by 2 0 0 to the power minus I 5 by 2. That is equal to az e to the power minus I 5 by 2 0 0 e to the power I 5 by 2 ax plus I ay e to the power minus I 5 by 2 x minus I ay into minus az e to the power I 5 by 2. That is equal to e to the power I 5 by 2 into the power minus I 5 by 2 equal to 1. E to the power I 5 by 2 into the power minus I 5 by 2 is equal to 1. That means this into this equal to az, and then this into this will be e to the power I 5 into ax plus I ay, and this into this will be 0, this into this will be e to the power minus I 5 ax minus ay, this will be 0, this will be minus az e to the power minus I 5 by 2 into I 5 by 2 equal to 1. So that means determinant of this u sigma dot a u dagger is equal to minus az square plus e I 5 into to the power minus I 5 ax plus iy into ax minus iy aiy is minus, so is equal to minus az square minus ax square minus ay square. That means minus mod of a square. That means its determinant is remain same. So we solve the first part of the question, that so that the determinant of sigma dot a is invariant. So we have shown that determinant of sigma dot a is invariant under the transformation is equal to determinant of sigma dot n. Now let us see the second part of the problem, that find ak dash in terms of ak. That means let us see that sigma dot a dash equal to sigma dot a dash equal to az e to the power I 5 ax plus I ay e to the power minus I phi x minus ay minus az. We know that sigma dot a prime will be az prime e to the az prime ax prime plus I ay prime ax prime minus I ay prime minus az prime is equal to az e to the power I phi ax plus I ay to the minus I phi ax minus I ay minus az. That means az prime equal to az and ax prime plus I ay prime equal to e to the power I phi ax plus I ay and ax prime minus I ay prime equal to the minus I phi ax plus I ay. Let us solve this equation. It will be, if we add these two, they will get ax prime equal to e to the power I phi plus e to the power minus I phi into ax plus, here there is a minus sign, I missed it, there is a minus sign, that means plus I e to the power I phi minus e to the power minus I phi into ay. That means ax prime equal to e to the power I phi plus e to the power minus I phi ax by 2 minus e to the power I phi minus e to the power minus I phi by 2 ay. That is nothing but sin phi into ax minus cos phi into ay. And similarly, we can subtract that two equations, then we will get 2a y prime I to a prime equal to ax e to the power I phi minus e to the power minus I phi plus I into ay e to the power I phi plus e to the power minus I phi. That means ay prime is equal to ax sin phi, sorry, here this will be sin phi and this is cos phi. So ax sin phi plus ay cos phi. That means this is nothing but we give an rotation phi around the z axis. We give a rotation around z axis phi. So that means ax prime is changed cos phi ax into sin phi ay. That means nothing but we give a rotation cos phi minus sin phi sin phi cos phi to the previous vector ax ay. So this transformation operator is actually the rotation operator. This transformation operator actually a rotational operator. So we solve the second part of the question also. So